Hi there, darlings. As promised, here's a tutorial on how to tackle the homework problems. These are examples of projectiles launched at an angle, but they're not trivial. You're not just asked to figure out the horizontal range or maximum height, something like that. Here we need to figure out the exact vertical position based on where the projectile is horizontally. To figure out the vertical position of a projectile based on where it is horizontally, we will find the time from the horizontal part and then deal with it accordingly. So let's look at our data. We have 36 meters, and that is the SX. Then we have our initial speed and the angle of the velocity, which is 53 degrees. By how much does the ball clear or fall short of clearing the crossbar, which is 305 meters high? We need to figure out how high it is in the air. And we're going to go and write all our data in the beginning. So our U is 20 meters per second. This was 53 degrees. And as always, the first step that you make, you figure out your UY and UX. So using trig, we get 20 cosine 53 for X and 20 sine 53 for Y. You're probably using radian in math, so make sure that you switch your calculator. Otherwise, it's going to be like fitting a square peg in a round hole or something like that. Anyway, so it needs to be in degrees. Otherwise, your calculator is just not going to understand you. 20 sine 53 gives me 1597 and lots of numbers. We'll just round this to 16 to make it easy. So 16 meters per second. 20 cos of 53 is 12. And they also gave us the distance to the goal being 36 meters. So that's our SX. And as you remember, there's only one formula for the horizontal part of projectile motion. And that is the formula that we're going to use to find time. How long does it take the ball to get to the crossbar? You know, simple switching. And we end up with T being SX over UX. Oh, how nice. 36 over 12. Aren't they sweet? 3 seconds. So now that we have our time, we can go for the time square formula. Again, make sure that you remember that UY, which was 16, is upwards, whereas G, 9.8, downwards. That gives us 16, 3 minus 4.9, because that's half of 9.8. Times 9, which is 3 squared. That gives us 3.9 meters. So ball, crossbar, don't you just love my AP art? It is definitely going to make the goal. So the answer is yes. By how much? Well, 3.9 minus 305. So that's going to be 85 centimeters. The second question is, does the ball approach the crossbar while still rising or while falling? In other words, we do know that it is going to make it. The picture that I have right now shows the ball already falling through. It could be that it's still rising and then starts falling past. Now we're back to our usual finding halftime. Finding halftime, as you remember, comes from this little formula here. G equals 0 minus UY over T. Therefore, T half is going to be negative 16 over negative 9.8. Cancels the negatives. 1.63 seconds. If halftime is 1.63 seconds, the time that it took to get to the crossbar was 3 seconds, so it's past the halftime. Therefore, it's on the way down. All right, so let's take a look at the second problem. Lots of scary numbers. 3 sig figs. Scientific notation. How horrible can they get, really? And look at this, they're trying to trip you. Ooh, 250, 250. If I divide this, I'll just get 10 seconds. Isn't that lovely? Nope. 250 is nobody's speed. And by the way, I'm saying 250. If I do this, 250, I just lost a sig fig, but who cares? We just need to remember that our final answer needs to have 3 sig figs. So 250 meters per second at 75 degrees. Again, the first step that we're going to make, we're going to split that speed of 250 into X and Y. U was 250 cosine of 75, which comes to 64.7. Let them have their 3 sig figs. 250 times sine of 75. That gives me 241. And I keep forgetting to tell you, you can even have it a shorter way. If you have your X, if you remember trig, if you know this, then that guy is going to be through tangent. So if I took this number 64.7 and multiplied 64.7 times 10 of 75, I would get exactly that number here. It's just, you know, good to know. It saves time, but you don't have to do it that way. Ooh, I'm forgetting units, meters per second. So they gave us the SX as 2,500 meters. I'm going to find time as SX over UX. That gives me 38.6 seconds. Technically it's 38.64, and if your calculator is nifty, you can even keep that time. But you know, for the purpose of the exercise, I'm just going to round it. So now I'm going to figure out where my projectile is at that specific moment in time, and we're going for time square formula again right here, remembering that this is up and that is down. So 242 times time being 38.6 minus 4.9 times 38.6 squared, 2040 meters. 3 sig figs, we're good. Oh my goodness, I'm writing so crookedly. Oh, sorry about that. So now let's see, how tall is our mountain? This is the height of the mountain, 1800. So then we just need to answer the first question. I'm going to do 2040 minus 1800, 240 meters. So they're not destroying the mountain. How nice of them. And to figure out where it lands horizontally, now this is what I'm looking for. So I can take this out, because now I'm actually looking for it. And I'm going to take this out as well, because it has nothing to do with the second part of the problem. Neither does this. So I know that force of gravity is going to give my projectile acceleration of negative 9.8, and that will cause the velocity of 242 to turn into 0 at halftime. So halftime is 242 over 9.8. I just skipped the canceling of the minuses. Technically, I would have to say negative 242 divided by negative 9.8. So 24.7 seconds. So if halftime is 24.7, then full time is going to be 49.4 seconds. And now I'm taking this time and using it in my horizontal part, because that's what I'm after. Right now I need to figure out how far horizontally my projectile traveled. So Sx is going to be 64.7 times 49.4. 3196.18, but I need to round it to 3 sig figs, so this is going to be 3200. Let's figure out how far the enemy ship is from where the cannon was fired. It's 2.510 to the third and 6.1010 to the second. Another way for them to trap you. You cannot add 250 plus 610. I mean, you could put it in your calculator, but that's extra work. If you look at the two different powers, my options are either to raise 610 to 10 to the third, so that will be this, or I could bring this down, and that would be 25 10 to the second. I like this version better, so I'm just going to say that it's 25 plus 610, 10 to the second, and that gives me 3110, essentially 3110 without any dots. So that's the distance to the enemy ship. My cannon lands this far, so all you need to do is just subtract now. 3200 minus 3110. We cleared it by 90 meters. Oh my goodness, 1 sig fig, whatever. You found it, you showed your work. That is what matters. You're not doing a lab. As long as you don't overdo it, make sure you do not go into this funny business. In the beginning, we were not sure about centimeters at all, so just keep your 90 meters. So there you go. That's how you do these two problems.